how we doing this morning? Everyone been alright?
Good.
Since I last seen you last weekend?
Bit wet.
Yeah, it's been a bit wet for today, but hopefully we're going to get in and get it done today. On today's lesson, we're going to be recapping a little bit what we expanded on from last week in regards to what we learned with forces, being the two of push and pull, being opposites. We're going to get onto that first. We're going to look at what we're doing in today's lesson. We're going to be identifying the forces acting upon an object. We'll touch base with that with a little bit of an experiment that we're going to get into. We're going to get into pairs and we're going to conduct a little test just to get a couple of results and have more of an understanding of what we're really trying to look at, which is understanding the difference between balanced and versus unbalanced forces. Knowing that, we're going to be, before we get into our test, we will predict how an unbalanced force causes change in motion. And at the end, we should be able to describe the effects of balanced versus unbalanced forces. Now, can anyone touching base on what we learnt last week with forces being push and pull, which is, a force is an interaction between objects. Thinking of it like there is an object and I'm pushing something away from myself. It goes from one spot further away from me. That could be at the shops, real life example, pushing a shopping trolley, taking stuff, putting in the trolley. That object is being pushed away from me. Do you guys have any examples of everyday examples that pushing occurs in our lives?
Opening the door.
Opening a door, yeah? Anyone else?
The bullies like to push me in bushes at lunchtime.
It's an unfortunate but very true example of when pushing can occur. And then obviously the other force is pull. It's the opposite of push. This is the force of moving an object away from ourselves, and there's obviously very certain scenarios in our lives that occurs. That could be pulling a door closed, or even pulling an apple off a tree when gathering. Does anyone else have any examples that happen in our everyday lives of pulling? Appropriate answers, please. Yes?
Like tug of war?
Tug of war. That is a great example of when pulling has occurred between two forces. Now, I would like for us to talk about the differences between balanced versus unbalanced forces. Does anyone here already know or have heard about balanced or unbalanced forces? Yeah, a couple nods, that's good. In today, we're going to just briefly touch on what balanced and unbalanced forces are. Balanced forces are when forces have an equal magnitude that act in opposite directions, keeping that object at rest or at a constant velocity. Nothing's going to change its speed or slow it down. It won't change direction. It's stable. Nothing is impacting that object in order for it to move in any other format than what it is currently. In contrast, unbalanced forces are where, when forces are not equal in magnitude and may cause the object to move from one place to another. Basically, they are not equal and they are opposite. They create a net force that ultimately has an impact on that object. So a good example is, Flint, could you come up here and demonstrate something for the class for me, mate?
Sure, can sir.
Just like your example with tug of war, right? I don't have a rope here, but can you interlock your finger with a hook, please? Can we interlock our fingers? And can you create a little bit of force between mine? Right now, we are both exhibiting the exact same amount of force. We are both not moving, hence there is a net zero force. This is an example of a balanced force. Flynn, could you please pull harder? I fell forward. Flynn exerted more force than myself, meaning the net impact of the force was created. A diagram I can show you in regards to what this looks like can be seen here. Just like this. Two teams up against each other, producing 300 newtons of force. the rope's not going to move because both teams are pulling the exact same amount. But if one team pulls harder, more, or one person lets go, they're going to lose force and the object will move. Touching base with this, I would like to propose a question. If we roll a car down a ramp, my little cute little toys, if we were to roll a car down a ramp onto different surfaces, which surface will slow it down the most and why? That's what I want you to think about. I'm gonna get you guys, if you can, jump on a Word document or your lab book or something, just write down your prediction to that question. If we roll a car down a ramp onto different surfaces, which surface do you think it will slow down the most and why? Any sort of prediction, anything you can think of, any reasons? Why you, yeah?
Are we given like different, are you gonna give us the actual like things?
Different
that
surfaces? Yeah, for example, for our experiment, I do have different surfaces that we will be conducting a little test on. It's pretty broad, it's what you think different surfaces will impact the car, but for our surfaces, if you want, what we're going to be doing it on is one of the bench tables for one surface, carpet for the other, and sandpaper for the next, for the third surface. But that's the question I want you guys to make a real quick prediction on is if we roll a car down a ramp onto different surfaces, which surface do you think will slow the car down the most and why? While you do that, I'm going to get you guys to quickly pair up. Once you guys are done, give me a nod when you guys have all made your predictions. Don't feel like you have to rush it or anything. Yep, cool. I want you guys to pair up for this experiment just to quickly get it done. In a normal lesson, I'm sure we'd have a lot more time and I'd like you guys to conduct multiple experiments, multiple tests to get reliability out of it. In this format, we don't have that time. So 1 to 2 tests, perfect. I'd love that. All you need is a stopwatch off your phone and something to write down your results. Word document, spreadsheet on Excel, whatever. It's really simple, really easy. I only brought one ramp, so you're more than welcome for this circumstance. Instead of pairing up, we're going to go into a group. Still the same collaborative experiment, but here is your ramp. I've kind of made a line where I'd like the back of the car to start. It starts up here, it's going to roll forever. Starting it there, let it roll down onto the surface, conduct your experiments and just get your times. I just want to see what time it takes for it to go here and stop on the surface. If it's too high up, feel free to start it lower. Just let it go from even the front of the divot and then just let it roll out until it stops. Once it stops, finish the timer, conduct your results. All right, if you guys can quickly jump into your group of 4 with the ramp.
I guess we'll do
Yep.
this first.
If you want to go to a different table that has no objects on it, or you want to bring it down just in case. Yep.
We'll do it here because there's a nice camera watching us.
Everyone have the timer up? I
Got it.
watch.
Everyone got a stopwatch. Sorted first.
Use this one off the edge. No, which one?
I don't know how to use a stopwatch.
I have a watch. Two and a half.
2.5 seconds.
Okay. Do you want to see here? Ready?
Yep.
And then
You get it?
There.
2. Yep, that was
Yeah, we got it.
that was 1.8 seconds.
1.8 seconds.
So the first one was 2.5, and then the carpet was 1.8. And the sandpaper, do you want to make like a yellow brick road in front
Yep, of course I can.
of our ramp here for me? Thank you. Okay.
Yep.
2.1.
1.3.
1.3.
Nice.
There we
Good
go.
job. Alright, guys.
So
Perfect.
the sandpaper was the slowest.
It was, wasn't it?
I mean,
Does anyone here know why it might be the slowest?
Friction.
Friction. Great. Friction is what will cause the car or any object moving against that material to slow it down, cause direction in movement, or cause it to slow down. Because the friction has that opposing force to the gravitational force that the car is exhibiting going down the ramp, it's going to slow it down. Hence why it would go further and stop a little bit later on a smooth surface because there's less friction. Does that make sense? Awesome. All right. Just really quickly, in your pairs, I want you guys to just jump into a little think, pair, share, just to quickly debrief about your findings, what you felt was the contributing factors. Just give you guys 30 seconds to have a quick chat about that, and then we'll go over it as a class and discuss our findings.
I was wrong. I thought the table would be the
Friction.
shortest distance.
Am I? Can't put up what was gonna be pretty close.
I wonder if I had a red Hot Wheel, it would go further.
Obviously, don't you know that goes faster.
Just something like, just some debrief questions that if you guys wanted to ask yourselves, just like what surface had the most friction? Like, how do you know? What forces were acting on the object? And how did the object's motion change when the surface changed? Did you guys kind of describe those in your little question time there?
Yeah.
Perfect. Okay. In regards to that then, guys, I'm going to quickly give you guys a little worksheet. We're all going to have one. It's just a very short response. Answer it the best you can. We're going to go over it as a class at the end, and you can mark yourselves accordingly. If you've got a pen, I'll give you guys a minute and a bit, or I'll give you guys 2 minutes to have a look through, and we can go through it together as a class.
I can't freaking write anymore. Honestly.
Give it your best go. It's all good.
I just need my handwriting. I can't write anymore. Because I don't write.
Oh, mate. If you want to write your answers in your laptop, feel free. We're going to go over it as a class anyways.
I can play from left. I'm a lefty.
True. Yeah, I'm just putting this on.
What force slows objects down?
Alright guys, we're going to go through these questions together as a class. Just feel free to mark yourselves right or wrong, give you guys an indication of what you've picked up in this lesson, and if you've linked that to any content knowledge. So the first question is what is the difference between the balanced and unbalanced forces? If you had something along the lines of balanced forces are those that are equal in magnitude but opposite in direction, keeping those objects at rest, whereas unbalanced forces are not equal in magnitude and may act in the same direction. Something along the lines, give yourself a tick. For the second question, what happens if forces on an object are balanced? If you had something like the object will remain at rest or continue moving at a constant velocity, will not change the speed or direction, give yourselves a tick. Give me an example of an unbalanced force. 3 that I have written here could be a ball being thrown, a fruit dropping from a tree, even a car accelerating, something where an object is moving. Give yourself a tick. Then we've got what force slows objects down when they slide across a surface. That answer was friction. This is the force that opposes motion and acts in the opposite direction of that motion. An example of that could be, shoes with grip on them. When you're moving really fast and you've got to change directions really quick, that friction helps you achieve